This is meant to talk about kind of the future and the vision of where this industry is going. And we have some incredible knowledge here. I've been fortunate to spend a lot of time with these folks over the years. But let's have a quick intro, Dave, if you don't mind, about yourself and your company, and then we'll pass around, then we'll kick off.
Yeah, sure. Thanks, Tony. And they got you doing double duty today.
Yes.
So thanks, everyone, for taking the time to hear a little bit about what we think about the future. Cogent is a global internet service provider, operates in 58 countries and 305 markets around the world. We carry about 2 exabytes of traffic a day, making us the largest carrier of internet traffic in the world. We connect to about 1,900 carrier-neutral data centers. In North America, we're also an ISP and about 1.1 billion square feet of multi-tenant office space. And then finally, we have a North American network where we sell optical transport or wavelengths.
Craig?
Craig Scroggie, CEO of NextDC. Company's been publicly listed for 15 years. We have 17 operational data centers in Australia. We'll open in Malaysia in March of this year, and we've just started building in Tokyo in Japan. The business does everything from large-scale enterprise and government, thousands of customers in that category, right through to hyperscale and out to the edge for cable landing stations and other satellite services.
Very cool. Thank you, guys. I mean, amazing company, and thank you for having us. Chris Stott, founder and executive chairman of Lone Star Data Holdings. We put data storage in space for disaster recovery and resilience that meets data sovereignty requirements. We put up the first 4 data centers in space back in 21, 22, 24, and 25. Our next mission heads to polar orbit this October, launching with SpaceX. We do various sales channel relationships with governments and others around the world, but disaster recovery in a way that's never been possible before.
Great. Craig, we're going to kick off with you. You've done some incredible things in the Australian market. You're expanding. I think, love to hear sort of where are things going? We've grown. I mean, the last 18 months have been crazy. You and I have talked a lot about this. We think the next 12 are going to be even a little bit more differentiated. But give us a sense of like what's happening in this space. You know, the hyperscalers are growing, but the enterprises are keeping up as well. They're starting to grow even more. It'd be good to get your perspective on kind of where things are going.
Yeah, I mean, this is an extraordinary, unique time in my 30 years in the industry. I haven't seen anything like the last 6 or 12 months. We sold more in the last quarter than we probably did in the last 4 or 5 years combined, and that'll happen again and again. And I think it's reflective of the fact that cloud has been one of the most significant and transformative forces that we've seen in the industry over the last decade, pay-per-use computing. But as we move into the AI era, the entire industry has changed and a new industry is being born. So the scale equation changes significantly to requiring power, and that is generating capability, transmission infrastructure and distribution on a scale that was never really contemplated in the past. And so when you think about the complexity of building and operating data centers, they are now very heavily intertwined from power right through to the operational side. So it is unique. We're finding first-of-kind problems, whether it's in planning, approvals, the scale of the supply chain, and just social license to operate. I think many of those challenges that large-scale industry have had over time, we are starting to experience in the digital infrastructure space.
Dave, transit is probably one of the most unique, and it still is one of the most important things in the industry of how we're passing this critical data. Where do you see this? It's obviously grown. I mean, when you and I started working together, it was we're going to buy in megabits. You know, we're at gigabit. We're at and it's just gone through the roof. You continue to grow your network globally. It's been an amazing what you've done, but it'd be good to hear kind of, hey, where's this going? Transport is not going away. It's only going to just get even more and more important in the future. But love to hear your thoughts.
Yeah, so our business is 26 years old. We've been public for 21 of those years. And we have been fortunate to experience unit volume growth of about 23% a year compounded. I don't think that ends. That continues going forward. We were founded with the basic premise that the internet would be the only network that mattered, and I think that thesis has proven correct. The product we produce are interface-routed bit miles connected to other networks. The inputs to that are optical transport, wave division, multiplexing, and optically interfaced routers. Fortunately, the costs of those two technologies are actually falling even faster than Moore's Law. The bad news is that the dollar value of that market does not grow. It stays static. So, 26 years ago, there were 200 global providers. Today, there's probably a half a dozen true facilities-based carriers. And what the internet did was separate the application layer from the network layer. I think we'll continue to see unit volume growth. I think the transformation that AI is doing will have a profound impact on networks. It'll drive another leg of growth, just like video streaming has driven growth, email has driven growth, file transfers have driven growth, gaming. Each application runs its course. And we're now in an inflection due to AI. But AI is going to be more symmetric. So the internet started as a symmetric network for email. It then converted to a more asymmetric network with content providers pushing things to end users. And AI is going to be more interactive, more iterative, more balanced. And that's going to have a meaningful impact on networks.
Chris, you have a pretty unique offering and kind of a cutting edge. Maybe talk a little bit about where do you see your business going? Also, kind of, are there other trends? Are there other folks that might follow on with a similar offering?
No, thank you. Well, when we started doing this, data centers in space was like, what are you doing? Data centers in space. We put off last two on the surface of the moon. Our next one goes up into Earth orbit, doing a lot more of that. And I think what we see is there's a lot of people talking about data centers in space. But when you look at the use cases, from AI training and inference is one use case. When you look at edge processing with data coming from space, that's one. And what we do is storage. But it all bottles down to everything that our colleagues on the panel do, everything you do too, Rory. It's all about data. It's the most valuable commodity the human race has ever created. Whether I came out of the satellite industry, my partners came out of the data center industry, this idea of we move it around the world, we process it, we store it, we protect it. And our goal is to use space purely as a new data center region. It's a region, ironically, that touches all other regions with unique power and cooling, fantastic laws that allow for data sovereignty, highly regulated. But it's a tool. It won't replace what's happening on the ground. It will complement it. It's the same way in different nodes of the internet. It's the same way different POPs and NOCs, and the same way we use satellites. Just a very good electronics in space, performing a function for a terrestrial marketplace and supporting that. That's what we do, and I think that's what you're going to see more of. The Googles, the SpaceX, the Amazons. Eric Schmidt just bought Relativity Space. OpenAI is doing their thing. It's absolutely fascinating, but it's just another tool in the toolbox.
Craig, talked a lot about where things are going in the industry. What are the obstacles? What are the challenges? I mean, nothing's ever going to be panacea. There's going to be bumps. You and I have experienced a lot of bumps over the years. We've talked a lot about those. I've talked to Dave about some of these as well. I'd love to hear sort of where do you see as you continue this incredible growth? There's obviously some challenges, whether it be in people power, whether it be in supply chain, but love to hear kind of where you think these things come up.
The constraint is not software in the AI era. The constraint is going to be all of the elements that are very long lead items that allow us to build and deliver in a reasonable period of time. When we'd planned data centers in the past, obviously you would focus on the network, and Dave's been doing this for a very long time. The thing that changes with AI is the order of magnitude shift. What was a 10 megawatt data center when we started building them, almost 15 years ago, became a 100 megawatt data center a few years ago, and now it's gigawatt scale reference architecture. You obviously don't build a gigawatt in a single go, but you may build it in 200 or 300 megawatt tranches. And so all of the elements that go into the construction at scale require a very significant amount of power infrastructure, and I think a lot of people would believe that generating capacity is the constraint in the energy system. But energy capacity, whether it's solar or wind and many other technologies, depending on the region that you're in, can be delivered within 9 to 12 months. But the transmission infrastructure in order to carry the electrons from the generating source to the facility, those long lead time items can be 2, 3 or 4 years. So for transformers for large scale HV infrastructure today, you are looking at delivery timeframes on 4 years. But when we're looking at supporting the rate of growth for AI, the opportunities will move to where there is available power and capability to be able to deliver. And so I think this is a very, very unique time, because we have two conflating forces bumping up against each other. We've got the transition to a renewable, largely renewable grid in most countries around the world. And so we're retiring coal and gas, but at the same time, we're bringing on new solar and wind. Firming becomes a critical issue for us. Cloud was largely built for resilience and elasticity, but AI is built for sheer performance and scale. And so that power needs to be there on day one. And I think probably the primary bottleneck is going to be in those larger transmission elements, because I think generation can be built within a year. The data centers themselves can be built within 9 to 12 months. But the large-scale transmission infrastructure and other substation components that need to go into the data center as an energy system now will be one of the largest constraints in the world.
Thanks, Craig. Dave, you've been through unique times, up and down, financial crisis. Love to hear about, as you grow forward, and obviously you run a public company, it's all about growth. What are the obstacles? Where do you see the challenges? Please.
So, I've been in this industry long enough to remember the dot-com crash, the telecom meltdown, the financial crisis, the impact of COVID. So there have been many ups and downs in the industry. And the product that we produce is a commodity. And to be successful in a commodity business, you need to have the lowest cost, the greatest scale, the broadest coverage, but because distribution is a natural monopoly, you need to offset that by being ultra selective about where you deploy infrastructure to get a high enough return on capital. I think we sit now in a crossroads of different trends that feel a lot like 99, 2000, where capital was being thrown at a problem and the value was being created, but the companies that deployed the capital were unable to capture that value. I think there's many of those same tenets here. The internet transformed the world. It made our societies more productive. It made consumers richer and gave them more choices. AI is absolutely as real as the internet and probably as transformative. AI exists today because of the internet, but AI will also change the way the internet is used. And it is not clear that the long-term path to growing AI is just throwing power at the problem, for the points around time, expense to build. If we look at the power infrastructure in the developed world, for the past 80 years, it's basically been premised on 2% GDP growth, 1% conservation efficiency improvements, so therefore 1% incremental capacity. Now that adds up over a long period of time, but data centers are a shock to a system that had only about 5% slack in the system. Today, conventional data centers use about 2.5% of all power in the developed world and are probably growing at 7 or 8% a year in their power needs. AI as a new application is today already using about 3% of global power and is growing at 25% a year. It's not clear that we can build enough power to continue to do things the way we're doing it today.
Thanks, Dave. Chris, super unique. As I think this is probably the most unique platform at PTC. You've launched similar sort of area of focus. What are you encountering from an obstacle perspective? I mean, you've launched something that's quite different than Craig, and that Dave also has data centers in his portfolio as well. Let us know kind of what are you seeing? Where are the challenges? But you're still, obviously, we're in this incredible growth from a data center perspective. What are you seeing? Where are the bumps coming up?
No, thank you. When we were doing this, it was all customer driven, and still is customer driven. When the customer comes to you with a pain point and says, "Help, please help me. I need a way of backing up my data. I need to do it under data sovereignty, and it needs to be preferentially off-planet to get away from all the wars and Sahara, all the weather wars, man-made mistakes, and everything we do down here, where it has value, to complement everything here." It was like wading through wet cement. It wasn't easy. It's still a push, right? We're doing a new use of space for data centers in very complementary ways, almost creating a new part of this industry. But as AI came on board, and when the big hyperscalers all of a sudden say, "Oh my gosh, this is a good idea," it does help. And so that's what we've been doing. It's like been pushing it. But for us, it's meeting that demand is huge. We have about 800 million in pipeline. And it's how do we push that forward? How do we get things, all the assets up that we need to? But then the other thing that's really important, and I think, please go check this. Go Google it, if that's what you want to do, or actually if you still use Google, or go use ChatGPT, which is what we use. Go look at the amount of data created every day. I mean, Dave, you said 2 exabytes a day. We look back in June 23, 4.5 quintillion bytes of new data was created by the human race every 24 hours more than yesterday. That's 4.5 exabytes. It was meant to double every 2 years. That was 23, 25. Did it double? No. It went from 2.5. It went from 4.5 quintillion to 402 quintillion bytes. That's way beyond an exponential curve. A lot of it driven by AI and the use and all of this. Then the hardware's coming in that's using more power, creating more data. It becomes the self-perpetuating, the self-leaking ice cream. It's unbelievable. And then we checked just before coming in today, it was at 702 exabytes a day more than yesterday. A lot of that is regulated data. It needs storage, it needs protection, it needs it under data sovereignty. Governments are now walking around the world saying, "Hey, that version of that AI, you let it loose. What did it do? Oh, we scrapped that. I need a copy of that." Right? It's all about the data. But that's the thing, and I think you were saying, I mean, we've all been through a lot. I started off in the satellite industry. I'm an old man. My first PTC was 30 years ago with McDonnell Douglas down here on the beach, right? And you look at these things, and you've seen the swath of the industry. And the one thing I say to my team is, this is still the beginning of the beginning. For us, we've seen all of this, and we think, wow, that's great. And it's like, it's not. It's going to keep going and keep doing amazing things. And I love PTC because it's the only place in the world where you've got data centers, data users, cable fiber, satellite. You've got everything you need here, very uniquely. You got all the other conferences around the world and they're amazing, but they don't have this unique mix. And I think that's the key to the future too, is all of us talking, working together to try and meet this incredible tsunami of demand that we're facing.
Thanks, Chris. I want to pause here for a second, see if there's any questions from the audience. Any questions? Don't be shy. These guys are great. They'll answer any question. None? Okay. Here it is.
How are you guys seeing the existing CDN architectures evolving with the AI wave of data traffic that's coming around? Is it more POPs, more cross connects, changing the entire architectural right?
I can throw in something. I don't quite know the answer to that question, sir, in a good way. I'll always let you know that. But I do see a lot more, or we see a lot more focus on sovereign. This idea of nation states saying that data is legally in my country, and if I'm going to use AI to run a government department, to help do something in our health service, to run a bank, it cannot leave that country. It has to be under the jurisdiction. So I think that itself will drive a lot of these connections, POPs, NOCs, and everything else. But it's all about sovereignty and that value of data and national control over it.
You know, I think if we look at data, data is the raw material of AI training. If you break AI into 3 buckets, 1, we have tokenization, very rapid price performance improvement, and we're continuing to tokenize all of the data that becomes the fodder for the large language models. The large language models, however, have not experienced that type of improvement because they're becoming much larger, much more power intensive, much more capital intensive in developing. And we're now at the cusp of the third piece, which is inference, and that is actually using the model. So if you step back and look at how AI works, every AI model takes tokens and does the exact same thing. They do it in different ways, but they pose a question to a data set that they already know the answer to and recursively question at until they develop a pattern of what the next token will be, and they take that pattern and project it into new applications. So AI only exists today because the compute power is there, the raw data to train is there. Now, inference is very different. In a training facility, over 50% of the capital in that facility goes to the GPUs. That's why NVIDIA is the most valuable company in the world. But that will change as we go to inference. It will still be tokenized, but probably a more diverse market, a more symmetric market, and one that creates more value. And I have one last point on software. If we look at software, for the first roughly 50 years of software was all about tabulation, faster, bigger models to tabulate. For the next 50 years, software was about process codification. And there were 30 million coders who wrote tens of billions of lines of code globally, developing processes that govern our lives. AI is changing that. It will destroy the software industry the same way the internet destroyed the telecom industry. It will make it agile, it will make it customizable, and it will make it more valuable. So we are in a third wave of software, but it will be radically different than the 2 previous waves.
Craig?
I think Dave really covered most of it. I'll just build on that, and I agree. Inference, if you think about the scale of training, it's big. It's a small number of very, very large deployments. And inference could be 10 or more times larger almost immediately. And assuming that's true, the sovereignty issue will become one that where is my data and who has access to it and what country can access that information. And so the role that the the system plays, the data center historically stored information, and the AI factory will create knowledge. And I think recognizing that the two perform a different role means that the size and scale of inference and the amount of information that will be, intelligence that will be created and exported, will also have a very significant sovereignty, security, defense, and geopolitical implication associated with it.
We're out of time. This was incredible. Guys, thank you so much for making time for us. Appreciate it.